Okay, welcome to week 4 summary. This week we were introduced to electric fields. We did our first project and we've been working on VPython on our own time. For the electric fields, we started off with gravitational field, and David helped us to think of it as a bowling ball in a rubber sheet. And basically, Earth would be the bowling ball and the rubber sheet would be space, and other objects would be pretty much forced to interact with Earth's gravity simply because the space was bent around Earth. And these objects could include, just about any object, including time and light, as they are both bent due to the gravitational field of Earth, or any planet for that matter. And electric fields work in a similar fashion, except instead of the bowling ball, it's a positive charge. And an electron would basically follow these valleys to the positive charge. That's that attraction between opposites. And on the other side, there would be a hill created by that positive charge. So other positive charges would basically hit that hill and be repulsed or repelled. And one of the big differences between electric field and gravitational field is the electric field has both an attraction and a repulsion force, where gravitational only has that attraction force. And as we see here, these are these formulas for gravitational field and an electric field or force, and they are very similar. Right here, the gravitational constant and the mass of Earth divided by the radius or distance. This is actually where the 9.8 newtons for the gravitational field strength comes from. And over here we're looking at a positive charge and a net charge, or I mean not a net, but a negative charge. And we see these lines where we have these arrows. And as they, this one's pretty straight, and as they move further away, they start bending, and so this is that space around them that is being bent. And here we see some of the math involved using the formulas above between two positive charges. Anyways, that was the basics of what we did for electrical fields, and we've been working on a homework assignment as well for that. We also did this exercise with this from fet.colorado.edu, which would be the University of Colorado, I'm assuming. And basically, this little sensor kind of tells you how the gravitational fields of these two charges are. This arrow's the net force. So if this positive charge would actually have kind of would show this vector going in this direction, while for the negative charge it would be going in this direction. And of course, if you added them up, this would be the resultant vector. And of course, we've been working with vectors through Physics 121, and we'll still be working with them here with the electricity and magnetism. And if we were to use two positive charges like this, we would still see much the same thing. This would be the resultant vector. You'd have basically this charge would be having a vector going in this direction. This would have one going in this direction, and when you add them up, it would be the tip to tail, tail to tip, and this would be your resultant vector from these electrical fields interacting with each other. So that's it for that. we did our first project, which was an Arduino project, and my group, me and Trey, did the crystal ball project, and this is the schematic for it, where the tilt switch was basically a way to simulate shaking a magic 8 ball. The LCD displayed the messages, and this is, not a difficult schematic to understand. And these were the parts that we needed. As you can see, it's not too bad. Here's the code for it that we had to program. And this is the code that was out of the book. Basically, we use the liquid crystal library, and this is basically the responses that we were getting. The switch statement basically offered 8 possibilities, and the statement basically would pick a random number that corresponded with these cases that would, anytime you shook the tilt switch. And then the other part of the project was to make some of your own changes, and this is what we did, and still set up pretty much the same way. It's up. We added a auto scroll and a blink feature to our code, which basically would, whenever we shook it, it would spell out this word and give up. One of the issues we ran into developing this was the LCD wouldn't work, and it finally figured it out. It was because we didn't have this command in there, which basically every time this goes through the command, it tells the auto scroll to turn off. And here's a video of that. Had to do it in the dark, otherwise my camera wouldn't pick up the screen. But as you can see, it spells out, and the blink moves along. It kind of makes it look like it's being typed up. Anyways, and here's the VPython, one of the VPython programs we've been working on. And this is lesson 7, projectile motion, which the simple one just showed an object being projected at an angle, but I obviously changed some of the values so that it didn't do that. And I also created this pad that would actually start 5 seconds before the ball started moving and would travel across at a constant speed. Meanwhile, the ball launched up and would decrease in velocity and then start increasing again. And here's this program. In the original program, the ball actually moved more along these lines, much greater arc. I added the little trail of dots to kind of show that. And show another program. Let's see, let's do 6. And this was basically an object that accelerated, and I made some changes to the values, as well as adding a cylinder that also moved. It starts 5 seconds ahead before the ball does, but it's at a constant velocity where the ball accelerates over time. And here's this program. And that's the VPython. And as I said earlier, we've been working with vectors all through Physics 121, and we're still working with them now. And so we're still using the vector addition. And it's, as far as how we're working with vectors, it isn't any different yet. But of course, now we're not applying it to an object's motion right now, but more of the interaction between electrical fields. And of course, this class does impact the degree that I'm going for, which is electrical engineering. So a lot of what I'll be learning here will be quite useful in school and professionally after I graduate. Two of the neat resources that I liked was the one that Nika posted, which was this article about Hackerspace, Makerspace, Tech Shop, or Fab Lab. And it really goes through some of the history and some of the differences, at least according to the author's opinion, between the differences between a hackerspace and a makerspace and so on. But it's kind of, this isn't something that I really knew much about before, so this is kind of gives you a good introduction to this type of creative spaces that are available to people. And obviously a little history and an introduction is certainly helpful for somebody that doesn't know a lot about it. And Luan also posted a link to Make Magazine, or Make Zine, my bad, which it has a number of different projects for all kinds of different things, such as simply building a guitar stand from a single board of wood, or as well as other technology-based, more technological projects. And but it also has some guides, events that are being held, but it also has a store so that you get for various hackerspace and makerspace projects, which is nice. I mean, it's obviously a big collection of many things. I'm sure there's a lot of advanced stuff as well as beginner level stuff here. But in a nutshell, the past week we've been introduced to electric fields and how they're similar to the gravitational field. And we finished project 1 and have worked on VPython, and that's it for the week 4 summary. Thank you. Bye.